This video is going to be designed to help students identify and classify different types of reactions. And you'll do this by looking at general formulas for each type. So, there's 5 different types of reactions: synthesis, decomposition, single replacement, double replacement, and combustion. We'll start off talking about synthesis reactions. Synthesis reactions are where 2 or more substances react together to produce a single product, and they take on the general form A plus B reacts to produce AB. So 2 things are just coming together here. An example would be where you have Na, sodium, coming together with chlorine, Cl2, to react to produce NaCl. Decomposition reactions are nearly the opposite of synthesis reactions. It's where you have a single compound that breaks down into 2 or more elements or new compounds. So the general form it takes on is AB decomposes to produce A plus B. An example of this would be hydrogen peroxide, H2O2, breaking down to produce H2O and oxygen gas, O2. The next 2 reactions are single replacement and double replacement reactions, and these are sort of related. So single replacement reactions are when the atoms of one element replace the atoms of another element within a compound. So here we have the general equation of AX plus B react to produce BX plus A. So here you can see that B is replacing A and combining with X to get BX. An example would be if you had magnesium and copper 2 sulfate reacting, CuSO4, to produce magnesium sulfate plus copper. Here, your magnesium is switching with your copper, and you get magnesium sulfate and copper all alone. Double replacement reactions, again, are very similar to single replacement reactions, except for the fact that here you're dealing with 2 compounds. So the 2 cations within the compounds will end up replacing each other. You can also see it as the 2 anions replacing each other. So this takes the form of AX plus BY, your 2 ionic compounds, and here your A and B are going to switch places, or your X and Y are going to switch places. You can see it either way. So you result with AY plus BX. So an example could be lead 2 nitrate reacting with potassium iodide, and here you're going to have your 2 cations, your lead and potassium, or your 2 anions, your nitrate and iodide, switch places. So here you're going to get lead 2 iodide plus potassium nitrate. The last reaction we're going to classify is a combustion reaction. So here we have some reactant reacting with oxygen gas to produce some sort of energy, whether that be heat or light. So the big thing you have to remember is that you always have oxygen as a reactant. So your general equation is going to be A plus O2 reacts to produce AO. An example could be if you take magnesium and react it with oxygen to produce magnesium oxide. Now, another type of combustion reaction you may see is the combustion of a hydrocarbon. And a hydrocarbon is just something that contains carbon and hydrogen. And the general form of this would be CX HY And remember, we have to have oxygen in our reactants for the combustion reaction to occur. So we have our hydrocarbon plus oxygen gas reacts to produce H2O and CO2. So an example of the combustion of a hydrocarbon would be the combustion of propane. Propane is C3H8, and we can add oxygen to it to combust it to produce water, H2O, plus CO2, carbon dioxide.